Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do data engineering and machine learning at Databricks. And I'm joined by my lovely co-host,
Ben Wilson. I write tutorials and guides for my code at Databricks.
And today we are speaking with Pierre Eliseeff. He holds an MBA from U Chicago Booth School of Business and a PhD in ocean engineering from MIT. Since then, he co-founded a company called Nodin AI, which focused on leveraging ML to automate business insights. And currently, he works at G2M Insights, specifically on the Analyzr product, which also sort of automates insights via non-code auto ML sort of type of solution. So Pierre, I would argue that developing business insights via sort of inferential techniques, A/B testing, that type of thing, statistics-based, that's the hardest branch of data science, in my personal opinion. So why have you focused on this aspect of data?
I think the reason we focus on that is we really we usually don't start from what's hard, what's easy, but we actually start with, hey, what are our clients or customers trying to solve for? And you always start with a business ask, and the business ask is usually, at least in what we do, something to do with a market-facing question. So if it's sales, it's like, where can I get the best customer? What should I need? What should I do to get my customer to close faster? If it's marketing, is where are the customers? Who do I target? And if it's care, it's who's going to leave or who's got a problem? How do I take better care of the customers? And to do that, usually you need to answer a question about why and how, because the first thing the executive is going to ask is like, how do you know this, or how do I know that this causes that? And then if I take a different action, what's called a counterfactual in causal analysis, how do I know this is going to work? So very quickly you find yourself answering these kinds of causal questions. And it's also key to, we haven't talked about this yet, but this whole black box issue in AI is real, not just as a technical issue, but as a real adoption issue for humans on the other side of the box. And answering causal type questions is really key in driving adoption and kind of making the box less black.
Got it. So just diving into the weeds really quick, How do you think about causality and how do you define it?
I mean, at its core, it's really, is X causing Y? And then to answer that, you have to come up with these counterfactuals. And what I mean by that is, well, if I had taken a different course of action, would I observe, this new prediction? And this is where you get into this whole business of, either propensity score matching or all these A/B tests that are all trying, if you don't already have a good set of tests that's kind of scientifically defined, it's how do we identify within the data good comparables where we control for all these confounding factors, and we can really validate whether, had you taken a different course of action, you would in fact have observed a different outcome. And that's the key difference between causality and correlation from my standpoint, which is when you look at correlation, one, you're less worried about confounding factors. You're less worried about this this counterfactual analysis, which is central in causal analysis.
So for listeners who don't know what the heck is being talked about right now, which I imagine a lot of the people that are new to the world of air quote machine learning and data science, this stuff goes back decades, like a long time. And everything you're talking about is giving me flashbacks right now to how I started into data scientist type work, which is at semiconductor factories, where there's a ton of money on the line for making a process change.
Yeah.
Where you could talk about, if you just use, your gut intuition on something, you're like, oh, well, if we just deposit this layer a little bit thicker, it should make our yield go up. If you do that, you're looking at $500 million in scrap if you get it wrong. So nobody lets you do that. Everything is approached from this hypothesis testing technique. Could you dive a little bit more into the differences when approaching modeling work for causality with respect to design of experiments, and why it's different than, supervised machine learning, for instance?
Let me make sure I understand your question. So how do we apply? I mean, I take your question as being how do we apply this in the real world in a business context where there's business decisions to be made, money to be made or lost.
Mhm.
And I think the key that we always have to address is this is not like the pharmaceutical industry where you can do these double blind tests and studies over years and understand what's going on and make sure that everything is apples to apples. Usually you have the data you have, and you may have tried to fill the data test. Usually those are market tests of one kind or another,
Mhm.
and there's always a bunch of confounding factors. And um, what happens in many cases, we see that all the time again with our clients, is people do the naive analysis of, well, we did treatment A on this group and treatment B on that group, and whether it's ad responses or just marketing campaign type of response rates, and it works better on this group, therefore we'll do it. And lost in that is this notion of understanding, well, what were the confounding factors that were in there? Did you account for them? Did you also account for the ones you couldn't account for? And are you factoring that into the analysis? And this is really where, as both analysts and executives, you have to understand, well, forget the mechanics for a second. Do I understand all the things that might have moved that the machine doesn't know about, so that I can try to identify these and go look for data so that I can adjust for these as confounding factors with my analysis. And that's really the key to doing these A/B tests the correct way. And that's the key difference with supervised learning. There's a lot of other gotchas in supervised learning, which I'm sure we're going to get into. But to me, that one of the key differences when we look at these versus standard, say, propensity scoring and supervised learning is really paying attention to those confounding factors and making sure that we can source proper data for them. Does that make sense?
100%. That's exactly what I was thinking. I mean, it's something that we do when we go into testing something like, if you work for a retail company
Mm-hmm.
and you have this giant pool of customers and
Yeah.
you want to say like, well, what if we put this product on sale in these 3 markets and see if it sells better? And that's that sort of naive testing
Yeah.
where it's like, well, which markets did you choose to do that in? And what are the demographics of the people there? What's the economy like in that place? What time of year are you doing this? Are you doing this on a particular day of the month? Does that correspond to when people in that region generally get paid? There's like all these
Right.
different like unknown variables that could heavily influence your
Yeah.
test.
You bet. I mean, another example we've seen, time and time again, is there's this kind of conventional wisdom in a lot of the subscription-based world that the more the subscription you have with a customer, the greater the number of subscription or services a subscriber subscribes to, the lower the churn. So the more the customer is likely to stick with you, it's a higher value customer, etc. So a lot of companies end up trying to sell more and more services to all their customers to make them sticky. Well, I mean, there's instances where we've seen, for instance, say in the telecom industry, you're selling things like you might have additional IT services like backup services or the like that you sell to people, and then you say, oh, if we sell more backup services to these customers, they will be stickier, they'll stay with us more. And um, what we've seen is, for instance, instances where the campaign was fielded and only the less tech savvy people responded and took up the service. And these less tech savvy people happen to be older, and they happen to be more on contracts and to be stickier because they're longer tenure, different demographic, different level of tech savviness. And so if you do the naive analysis, you're like, well, selling backup services, works because we see lower churn and higher value within these demographics. Once you adjust for the fact that the two groups are not the same, you realize that within that older demographic that is stickier to begin with, in fact, having these backup services yields more churn because people get frustrated with the service and they blame you for all the tech issues they've had and they move somewhere else. But you didn't see that if you weren't paying attention to those confounding factors because you just assumed it was a good thing when it turned out, in this case, you probably don't want to sell tech services to these less tech savvy demographic because they get frustrated with it and they blame you for it. So that's a typical example where doing the causal, the A/B test analysis the right way leads you to the right decision, which is maybe we should stop selling backup services to these folks or sell it in a different way, as opposed to what 80% of people would have done, which is, yeah, let's go sell more of it. And then you can replicate the results, and ultimately it leads to more churn, which is the inverse of what you wanted.
So what advice do you have for somebody who is doing the naive approach for testing, but they want to move into a more sophisticated understanding of what they're trying to drive for their business? What's the best process that you can recommend to somebody to say, here's how you can break down a problem in order to either collect the data that you need in order to test your theory, or you leverage the data that you already have in inventive ways, or just to start that thought process to say, what should we be questioning about this?
Yeah, absolutely. It's you know, uh, it always goes back to how do you structure the problem. So what I see in most cases, I see all the time, people don't take the time to structure the problem, and then they don't take the time to source the data correctly. And I want to explain on that a little bit. So a lot of people that are new to data science or new to business focus on what their comfort level is, which is doing a lot of data sciencey things, a lot of hypertuning, or a lot of whatever seems useful. What they're not doing is taking a step back away from the tedium of bookkeeping and Python coding and all these things, and actually thinking, okay, what is the problem at hand? What are these confounding factors? If you don't know what the confounding factors are, go talk to people. There's probably a lot of domain experts within your company or your team that actually have seen these things before, and they may not understand the data sciencey portions of it, but they'll know that historically there's these 3 or 5 things that always seem to mess things up. You want to identify what these things are, and have at least hypotheses around what they are, and take time to structure what that is. The other thing that's also really important in terms of structuring the problem is understanding what the outcome is. So making sure that you agree and understand that the outcome you're trying to model, whether it's churn or conversion rates or whatever it happens to be, is the one that matters to your audience and to the problem you're trying to solve. Once you and take the time to do that, because it'll drive a lot of issues down the road if you don't structure that problem the right way. You'll come back with an answer that'll be just irrelevant to most people. The second thing is go get sources rather than hyper tuning and hyper optimizing the data that's not the right data for you. Go fetch within the organization. So I know the scope we have for this discussion is larger enterprises. The thing about larger enterprises is they have a ton of data. Most of it is underutilized, and most of it usually sits in silos because people being people, one department hoards their data and another department hoards their data. And even though it might be in the same data warehouse, the two data sets rarely talk to each other. And even if they do, there's always all kinds of issues. So spend some time understanding what your data sources are, where it resides in the organization, build relationships with whoever owns that data so you can actually access the data, and get your hands on that data. And if you do those two things, then the last piece on that is obviously get familiar with the mechanics of causal analysis. So start with something like propensity score matching, which is a fairly simple technique. There's a lot of libraries out there, whether it's Do-Y by Microsoft, it's now been adopted by Amazon as well. Causal inference and others. There's a lot of libraries you can use if you're adept at Python that will get you a long ways. And so do propensity score matching. Ignore the academic noise around the validity of it. It tends to work really well in practice in a lot of cases. And I'd say start there. Obviously, if you have an aversion to Python and you want to do more of a no-code type approach, we have tools for that. That's what we do at G2M with our Analyzr platform. But you don't have to use it. Just again, to start with the basics, which is define the problem, source it in a way that's relevant, and understand the basics of propensity score matching.
I really liked your first part of I liked both parts of your answer there. I think I could not agree more with either of them. That first part of that answer, I think that's like 2 or 3 chapters of the book I wrote on ML project development was exactly this. it's the most important, in my opinion, years of doing data science work with multiple different industries. If the data science team or the analysts, the machine learning engineers, whatever you want to call the people that are writing the code and building models and providing solutions for the business, if they're not starting that project with the actual people who know what's going on in the room, you're never going to get as good as it could be. And a lot of times you'll get nowhere, and you'll produce something after months of work that nobody ever uses because they're like, this doesn't solve this really big problem that we have, or it doesn't really work when we apply it in the real world, because they'll start picking it apart if they understand how it was done. They're like, oh, you totally forgot about this one big part of how our business works. Why didn't you come and ask us?
I agree. Yeah, we got brought in one time to fix somebody's retention, retention propensity, churn propensity model, and they were concerned because the model just wasn't performing as expected. And here's what they did: they spent literally millions of dollars setting up their data environment. They brought in statisticians and data scientists to have this huge churn propensity modeling, so a model that predicts whether a customer is going to leave or not. And 3 months later, they presented their results back to the executive saying, we've identified, with a great degree of certainty what drives churn. It's this one factor in the system. And there's this one variable coming out of the data warehouse that tells you whether someone's going to quit or not. But they weren't sure what the variable, what the feature was. And finally, after they presented and they did a little digging into what that feature was, it was the flag in the system when somebody calls the call center and talks to a retention rep and says that they want to quit, they get flagged.
Uh-huh.
And that was like such a great leading indicator of people churning. Well, yeah, because they've told you they were going to churn. And it was kind of embarrassing, obviously, but it's typical of what you're describing, which is you don't want to be that guy or gal without domain expertise, just going to town with fancy statistics on a data set and not having that domain expertise with you. And if you don't have it, it's absolutely okay to reach out. You need to talk to people for sure.
Yeah, I just want to quickly shout out this as one of the most common issues you see when people transition from predictive ML, where they don't care about the why, into inferential modeling. It's not a Kaggle competition. You actually have to know what the features mean. You have to use proper techniques, handle confounders, have correct data, correct models. All these things are very different from the standard ML 101 or follow-up blog post. You actually have to get in there and really understand the problem.
Yeah.
Because just having a predictive feature is not enough. Because like you said, sorry, go ahead.
I was going to say, I feel actually strong, even for predictive ML. I mean, I feel strongly about this because in a lot of cases, at least in the work that we do, we use predictive ML for things like propensity scoring. So you're scoring accounts and you're asking your sales leadership, for instance, to go focus resources, so people's time and money, on prospects that we think are better. Their own livelihood is at stake on this. Their commissions, their promotions, career promotions and whatnot, is that they're not going to do that on some weird esoteric prediction if they don't understand it. If it's a black box, we've seen that time and time again. Nobody's going to act on the black box because, I'm not betting my commission plan on this black box. And so what we do, even with just pure predictive ML, is we spend a good amount of time up front actually briefing the senior team on here are the findings from the model. Here's the feature importance chart and what it means to you. Here is, we can get out of that what a high likelihood to convert account looks like versus a low likelihood to convert account. And these are the types of activities you got to do that drive sales. And typically when we present that to the team, half of those things they already know in their guts because they have experience, but the other half of the findings they don't know. And they get really excited because they're like, oh, now we can quantify the minimum effective dose for each touch point. And you've shown me, you've validated things I already knew. And then I've learned a thing or two. I understand how the model works. I understand where the prediction is coming from. Now, when it shows up in the CRM, I'm actually going to act on it because I trust what's in the box. And it's a really underappreciated part of doing predictive ML in the enterprise, which is you can't just do what you just said, which is Kaggle the heck out of it. You have to talk to the people that are going to take action based on it and make sure that they're comfortable with that technology so that they can make their own bets with it. Otherwise, I've never seen anybody really act on this without them being briefed first.
Yeah, this definitely reminds me of the first time that I worked with retention data years and years and years ago. I'd been working in factories and stuff and doing completely different types of modeling of like, hey, I'm trying to optimize this process. So I'm
Yep.
doing a bunch of integrations over these different, you know,
Mhm.
parameters, and that's a different field of ML. And then
Yep.
come into an online, company that has a bunch of human customers, and somebody's like, well, we have this model that somebody built. They were a student at this company that came over as an intern. They built this thing. It's super sophisticated. And I was like, okay, well, what does it do? Um, they're like, well, it's in this thing called TensorFlow. I'm like, okay, it's a deep learning model. Can I see the code? And share this notebook with me. And I'm like, this is running in production right now. It's a
Uh-oh.
Jupyter notebook. And they're like, yeah, it's amazing the predictions that come out of this. We don't really know how it works. I'm like, yeah, nobody knows how this works.
Mhm.
Um, and I certainly can't tell from the code what's going on here. What's the data being used? They show me. I look at this data set, and I'm like, this is like a Cartesian join of all of the customer data for the company.
Mhm.
Uh, this is joining 90 something tables uh, and just thousands of columns. Like, how is this model learning anything from this that
Right.
we can interpret? And they're like, well, we started to act on some of the predictions. Some of them were really good, and then some of them were really bad. And we think that our interaction with the customers to try to like bring them back to buying from us actually made them churn. I'm like, you're probably right. You probably annoyed some people. So let's like, what do you want this project to do? And we sat down for a period of 2 weeks, every single day for a couple hours with me and this
Mhm.
team. I said, well, what do you need? And they're like, well, we want to know who we should send, re-engagement emails to, and who should we send coupons to, and who are our biggest customers that are going to be coming back. I was like, I have no idea what you're talking about, but I'm going to go read some books and I'll be back. So I read up on customer lifetime value and like this whole
Mhm.
marketing philosophy.
Right.
Um, Learned a ton, and I was like, I don't think this math is too terribly complex to figure this out. I think this is just like basic statistics on population analysis, and wrote some code up and presented it to them. And they're like, this is exactly what we need. And they were checking like historical records from what the estimations were of these assignments of customer groups and their value scores.
Right.
And they're like, this is so accurate. I'm like, I didn't invent this. Like, here's the person in 1955 that came up with this. And then here, I just implemented this algorithm from somebody from 1978. And here's
Right.
their paper. So this is a solved problem, but here's the code, and we can look at this together. And it became a real eye-opening moment for them, like seeing the difference between somebody building one of those black boxes, like over engineering something in in a way that didn't need to be engineered in that way. But what opened my eyes to that interaction with them was the inclusiveness. That's what they really valued, was like
Absolutely.
just asking, like wanting to hear their opinion.
Yeah. I mean, a couple things come to mind. One is at least in my own experience, TensorFlow and neural network type methodologies are really well suited to unstructured data. But in the world I live in, which is mostly tabular data, it's just not that effective. So a lot of the more the more traditional machine learning techniques that are not in TensorFlow tend to be actually way more effective. That's one thing. The other thing is, one of my favorite gotchas for this kind of work is, and you might know the answer to that, but most people don't think about it, which is when you're trying to do this, you have to come up with, well, what is the outcome we're trying to model and predict? So is it people responding to an email? Is it people buying from us? Is it people calling us? Whatever it is. And people tend to have some idea about this, but then quickly you get into, okay, that's the positive outcome. What's the negative outcome?
Mhm.
So let me explain. Like if you're trying to figure out who's going to buy from you, for instance, the positive outcome is people bought. Great. So what most people do is you go to your data set in your CRM system or customer database of one kind or another, and you take everything and you say, okay, I've got all these people in my database, and these are the ones who bought. And then if you haven't thought about it, you're going to go train, your predictive model, your machine learning model on that data. The problem is you haven't thought about what the negative outcome was, which is people didn't buy. Okay, they didn't buy why? They didn't buy because you pitched to them and they said no, or they didn't buy because you never tried to pitch to them and they've never heard of you. Because if they've never heard of you and they've never been marketed to, that's not your negative outcome. That's just the addressable market you haven't gotten to yet. You should not include that in your training. But you'd be surprised how often people don't think about that. And that applies to virtually every supervised learning problem that we have, which is to think through the positive outcome. Usually, if you take your time, everybody's clear on that. Nobody's ever clear on what the negative outcome is. And it's really key to understanding what training data set is relevant. And if you don't do it right, you end up with results that are not, that you can't reproduce, that actually are not that predictive.
Yeah, that was something that I saw in that original solution, was like that exact data where it was customer data where, because there's a website and an app associated with the company, you had data about how many times somebody had visited the site and how many pages they viewed and how many products they viewed and what their stay time was on different pages. And I remember looking through the raw data and saying, this person has 1 second on the site for their entire lifetime. So they clicked on an ad and then bounced back to wherever they were going. It's not a visitor. This isn't a customer. But what we can say for a negative sales is, what about this person who has spent 73 hours over the last 3 months browsing our website? They have thousands of page views that are consistent with human behavior. It's obviously not a bot that's doing this, with no purchases. Maybe that's somebody that we need to understand what their behavior pattern is. But instead of us, we can't look at all 13 million of those customers individually. Let's see if we can group their behavior patterns together and create some sort of cluster of these type of customers have these similar behavior patterns, and then let's analyze their data. Let's look at it from a time series perspective, from first event coming on the site, and then what do they actually look at? And we had this really cool app that we eventually built, which would simulate somebody's journey from what the page was at that time and point, and you could sort of play this movie that would show the different pages that are being viewed. And we weren't looking at that. I have no idea. I'm not a fashion expert. So I just went into the fashion experts and say, if I show you these, what do you see from here? Give me your insight, whatever pops into your head. Just write it down for me, or say it out loud. I'll write it down for you. And the insight that we got from that, where it's like, oh, this quorum of people all agreed with these patterns that we're seeing. And now let's talk to the marketing team, and all of us work together and say, does our site suck? Like, what is wrong here? Like, why are these people not converting? And some of the insights that came from those discussions eventually made it into ML solutions, but it wasn't approached
Any
the other way.
insights you can share that are not proprietary?
Definitely not. I think I'm still under NDA about stuff that was built at that company. But if we, as an ML team, had been forced to do that, and I've done this, I used to do what Michael does right now at Databricks, dealing with all these different companies trying to solve problems with ML. And if in any of those situations or organizations, if the ML team was left to its own devices, they always come up with something that it appears to be mathematically valid, and it appears to be scientific in nature, but it never really solves a problem until you have that, like, hey, who cares about this data and this project that we're working on? Can we please get them in the room right now? I don't even want to talk to the data science team. You guys are irrelevant. Well, just listen. Don't talk, just listen. unless you have a question to ask, and then just listen even more, and then just have these people explain what their problem is and what they're trying to solve. It's so effective.
Yeah, I could not agree more. We see it all the time as well.
So question for you, Pierre. There's often a pretty hot debate, both, I've seen this debate rage both at Databricks and then internally at prior companies, uh, when we're thinking about creating an alpha or a type 1 error rate. So in frequentist statistics, you bound your errors via parameters alpha and beta, and specifically in the A/B testing realm. And I was wondering what values you think should be put in for alpha. And the typical 0.95, I think that came from lenient medical research, and then the 0.995 is the real medical research. Some people go all the way down to 0.9. So how do you think about setting this parameter?
I mean, I think to me, it boils down to what your tolerance for risk is, right? It's all about, all it is you're supporting what I think of as decision under uncertainty. I mean, you're ultimately, this is about, think of a business as a big resource allocation machine, and all this machine learning is just gobbledygook to help the allocation of resources be done mostly, more right than not. And so if you're looking at decisions that are easy to reverse and you just want a batting average that's better than most, think of it as you might be more risk tolerant because you know that you reverse the, if you end up with a false positive, you can reverse the decision, and you just want fast decisions that are, that have a good batting average over time. And then, a confidence level of 90% or your alpha of 0.1, that might just be good enough as long as it enables quick options and you have a lot of at bats. If you're looking at a decision that is hard to reverse, that is costly, where you really don't want to make a mistake, then obviously that changes how you look at it, and you want an alpha that's much, much lower. You might be, I mean, this is what in some cases refers to as the 4 nines, the 5 nines. I mean, I've done a lot of work in the telecom world, and back in the days, everything had to be 5 nines, meaning everything needed to be reliable and known with 99.999%, reliability. If that's what you want, I mean, it's going to cost you, but do it that way. Most decisions will not be that way, by the way. Most decisions, in our own work, I think we do a lot of work somewhere between 1 and 10%, depending on exactly that, which is how important is it to you that you be right every time?
Right. And so in the move fast and break things paradigm, you might want to lower that alpha. But then how do you recommend doing sort of a second pass of analyses to see if actually the feature is problematic and you did experience a false positive?
Yeah, I mean, I think you should always go back for sure. You should. I mean, now we're getting to the what I think of as model drift, and whether you have data drift and or concept drift, you always want to go back weeks and months later and look at what the models produced and whether it in fact came true or not. I mean, we do that all the time with things like propensity scoring. We want to see if, well, the accounts we said we're going to close, did they actually close? Did it produce something for real? Because it's ultimately the real test as to whether you're doing work that's valid or not. And you should always do it, yes. And the way to do it is the way we do it is we monitor the statistics of the data sets, the new data updates that you're ingesting, making sure that they're still in line with what you trained on. If they're not, you probably need to retrain. And then we try to identify also what's known in jargon as concept drift, which is our old features no longer relevant. So for instance, what we a thing that I always watch out for is, especially with new products, when you migrate along this product lifecycle of going from early adopters to a more mature customer base, you're going to see factors like pricing taking on a different importance. So pricing may not be relevant to early adopters when you're trying to identify your targets. It may be very relevant to late adopters and majority type customers. And so this is the type of, non-stationary type issues that you need to monitor over time. Absolutely.
Right. That makes sense. And then just one more point. So there's a bunch of different ways that you can actually go validate whether the experiment results have held over time. And just sort of taking a step back, first things first, with A/B tests, you have a finite time window. So for long-term treatment effects, sometimes you won't capture that. And So monitoring over time, the classic one is synthetic controls. It's hard to scale those, but I've seen those work really well. But the easiest thing typically is doing a holdout experiment if it's an easily reversible feature. So basically, turn off the feature and then see if there's a drop in your North Star metric. That indicates that the environment that you tested in is still available and sort of relevant. But now a question for both of you. All right, we have sort of let's say a mid to small size company. Let's throw ourselves in a retail vertical or a digital native vertical. We sell stuff online. How do you think about, let's say you're the CEO or the CTO, how do you think about scaling causal decision making throughout the organization? How do you democratize it? Do you hire a bunch of really good causal analysis people? Do you improve your data quality? Do you run a bunch of A/B tests? Do you use automated solutions? How do you scale this framework?
I mean, for me, it depends on who we've hired at the company. If we're a tech first company, like we produce a software product that the demographics of our company are a bunch of software engineers, then maybe a couple of specialists get hired on to build tooling internally that's a little rough around the edges, but it gets the job done because a bunch of engineers are going to be interfacing with it. It's probably the cheapest thing. For the other 99% of companies out there, I would use a product like what Pierre's company produces. You want to democratize this in a way that there's no massive barrier to entry. So if you say, hey, we're standardizing on do Y, which I've used that software before as well. It's fantastic. And it can confirm, as you said earlier, it does work in the real world very well. But are you going to send everybody in the company through a 2-month training program to understand the fundamentals of causal modeling? No. Are you going to teach everybody how to write Python? Probably not. Are you going to teach everybody how to write good Python? Good luck. So a no-code solution that provides compelling visual results, as well as all of the additional data that meets the needs of lay people, where they can get an answer that they can trust and understand it, as well as more sophisticated users. I think there's a big myth of people who are like, well, engineers who can build stuff, they never want to use GUIs. I'm like, I don't know what those people are talking about. I love using stuff that automates away stuff that I don't have to code up myself. If it solves my problem, I would prefer that. So providing additional information for experts to review in a UI tool like that is fantastic. So that's the direction I would go. Just open it up so people can use it.
Ben, you did a really good job of summarizing why we built that product. So I appreciate that. I think it's a broader question though, that yes, the tools definitely matter, and I completely agree with Ben and would echo that. You're never going to have your employees become these advanced data scientists. Most of them are not going to be doing all the coding and the bookkeeping and whatnot. But you want to sensitize people to, hey, don't be naive about doing these A/B tests. Be more data driven. And really, as a business person, your mantra becomes, how do I become more data driven as an organization? And there's actually, it's a multifaceted problem. The first one is make sure that you have the data environment, the data ecosystem set up right. Most companies do not, and they're still kind of working on it. So have an initiative internally or a group of people who look after your data environment so that it's ML friendly and it's reasonably well connected. So really fight the human tendency to have data in silos. Make sure that all the data sets can talk to each other, because that's how you're going to get that 360 view to be data driven. So I would start there, and I'd say half the people we talk to are aware and focused on it. The other half is still kind of fighting amongst themselves. That's step one. Step two is make sure that in your business decisions, you're actually data driven. I mean, I've worked at large companies. You wouldn't be, I mean, it was always amazing to me to watch, up and coming executives presenting what I would consider fake data, or data that's just false or misleading or just plain wrong, like the math doesn't work, but then presented with such aplomb and confidence that the decision would get made even though the data was wrong. Well, it's again up to the principals in the business to make sure that that doesn't happen. And that's not a machine learning issue. It's a kind of data and numbers literacy type issue, which you got to be aware of. And then again, going back to Ben's point, put the right tools in people's hands so that they don't have to do the complicated math themselves, but they know that if they have a marketing campaign, for instance, yeah, think about what your confounding factors might be. You don't need to be, a math whiz for that. You just need to pause and ask yourself the question and go talk to the people who know, hey, what might have changed between these two groups, and why should I expect this to be reproducible or not? And that's really, to me, at the core of being data driven.
That was flawless.
Brilliant.
Yeah.
Yes.
We can end now. Yeah, that perfectly aligns with sort of what we've been saying, and what I think at least Ben and I have been hearing over the years is you sort of want to ensure correct data, ensure you're asking the right questions, and then put the right tools in the hands of the right people. Looking towards the next 2, 3, 5, 10 years, do you think that we will be able to automate some of this decision-making process via advanced machine learning?
I think the technology will definitely be there. What I don't know is whether people will be ready to accept it. Because I think if you think about, and obviously we're going to expand on that, but the people's livelihoods, the thing that's fun for me solving business problems is that people's livelihood depends on it. There's very real world implications of what you're doing. And so there's all the standard, human passions and dilemmas of the human condition that get wrapped up in these things. And if you put a machine in charge of allocating resources that ultimately touch on people's income, career progression, resource support and whatnot, there's going to be a huge level of discomfort with having that be automated without a human in the loop. And I think that's actually a much bigger barrier. When you think about the insights themselves, it all boils down to understanding, a couple of kind of archetypal problems around: can I detect an anomaly? Can I detect things that are alike? Can I optimize an objective function, whether it's profit or revenue or anything else? The machine learning, architecture and technology is already more or less there. It's just that the acceptance is not there yet. And a large part of what we did in my previous venture at Nodin was exactly that: was automating the insights so that you could get to the decision point faster. And one thing we found out was people weren't ready to automate insights. They didn't want that. They wanted tools so they could get to the insights with the tool. But to not even be part of that loop and just see the insight happen, that was actually scary. And I think that's something, technology has always had this scary element to it. And I think that's what will overcome it. Even if you look at like this whole topic of AGI today and all the call for moratorium that was, that happened over the last year or two on LLMs and whatnot, at its core, it's the same fear of, hold on, this is going too fast. We need to keep that human in the loop element. We can't just depend on the machines. And I think to me, that'll be one of the largest issues we need to deal with and grapple with within that AI field of the next 10 years. It's how do we use it? How do we live with it? What's acceptable? What's not acceptable?
From my perspective, the way that I see integration of these classical and extremely powerful statistical modeling techniques with the new advances in stuff like transformers-based LLM models is the same way that I interface on a screen to my right now, GPT-4 is up. It's always up. Yeah. It's my personal assistant for stuff that if I want an answer and I don't want to scroll through a bunch of terrible Stack Overflow posts or try to find some reference to some esoteric knowledge that 80% of the responses to it, I know I'm going to have to read through. I know it's going to be garbage. I'm not going to even test it, but I can ask GPT-4 like, hey, this Python package, I've never heard of it before. What does it do? And can you give me an example of using it? And it generates it. I can copy, paste the code into an execution environment, run it, and say, "Oh yeah, I grok that. That's cool. Now I understand a little bit more." And I'll do that so much with examples like that. But recently, I've been having to do a bunch of web development. I'm a backend engineer, so I know nothing about website design.
Mm-hmm.
GPT-4 knows quite a bit about website design. So if I, in plain text, explain, hey, I want this element that does this and also does this, and then it provides this sort of spacing between this other element in this container. Can you generate the CSS for me and then HTML code example? And then I also want a JavaScript component in base JavaScript that allows me to do this with this animation. And in seconds, I get this tutorial, basically custom crafted for me, because it has all that context history of this 400 pages of text that we've been going back and forth with.
Mm-hmm.
I imagine that process being applied to a tool like what your company has built, where it's an assistant that's there to help you through, to say, hey, do you see any other insights that I might be missing here? Or could you recommend our next iteration of a hypothesis test, and for it to analyze the data or the results of the previous and then generate 3 or 4 options as sort of an efficiency booster? Like stuff like that as an integration, that's where I see the success coming.
I agree.
The automation side of it, I 100% agree. It's not that I don't trust it, it's that I know how it works. So I know how generative AI produces what it does. So I'm like, I would never connect that to a production system that is automated, unless it's just a chat bot for people to mess around with. But making decisions, it's inherently flawed because it has no real context. But as an assistant built in to analyze discrete results of things with context, I think that's the future.
Yeah, for LLM specifically, I agree. Now, when it comes to making decisions, there's a lot of non-LLM, techniques and technologies that you could use. I mean, RL and a lot of other things that actually would work given the proper data.
Mm-hmm.
But for the same reasons, you want to keep a human in the loop. I think you will not in the near term, even in the midterm, get any adoption if a human's not in the loop.
Yeah, it's just too much risk.
Yeah.
Got it. So we're looking to create cyborgs, or essentially augment human functionality. We're not going to give Terminator full control yet. Is that what I'm hearing?
I don't know any legitimate business leader that's out there running a company who's going to say, yeah, sounds like a great idea. Let's have this thing that we don't know how it works automate our business. Like, nobody's going to allow that to happen. You do it as a test. Say, well, what would happen in this sandbox environment that's not connected to the outside world? Let's see what happens.
Here's where you're going to see that pressure come from, and we see it today. And I don't think it's a 1 year, even a 5-year thing, but I definitely think it's a 10-year kind of trend, which is you see it today a lot in the private equity space, which is, if you guys have ever dealt with private equity investors, you know that they tend to be much more quantitatively driven, much more data driven. They typically want a ton of data from their portfolio companies, and they can be very hands-on. And traditionally, even though the mindset was already there, there was always this dichotomy between the management team that owns the data, that is privy to the data, and then discloses a subset of that data to the owner, right? It's the old capital versus labor, owners versus employee type, relationship, or principal agent relationship. What AI and machine learning and all the modern data stack enables is that data hungry owner can now have better, more granular, more real-time visibility into the business and can bypass the employees. And because of technology, you can scale the ability to make decisions, to make more decisions over a broader scope of companies and geographies and products and all that. And that is shifting a little bit the dynamic between these owners, these company owners, and the employees, because with the help of technology, you can start automating the more menial tactical decisions. You can start getting really good reporting and visibility. And over time, I mean, I'm convinced it will change the boundary of companies, what the right boundary is for the firm in terms of what's the proper collection of individuals and capital that's needed for one company versus a whole portfolio owned by a fund, for instance. And I think you'll see less separations between these companies and more kind of network and collections of assets run by some central group happen over time, entirely because of technology and the modern data stack and AI.
So do you think stuff like that is going to keep us from Theranos sort of startup activities? It's like, hey, if
Can
the
you tell me
data
more?
was actually disclosed to the VCs and they had full visibility onto like, what's actually going on here.
I think so. Yeah, that's a tricky question. So let me answer it carefully. One is, to the extent there's bad actors committing fraudulent actions. I mean, that's human nature. Crime is not going to stop. I mean, it's been going on for as long as there's been people. That's not going to stop. But to the extent you now have data that is in the hand of systems in a machine with controls without human intervention to bias the data, it's going to give more visibility to the owners and it's going to be more of a control. Yes.
Follow-on question. You can feel free to refuse to answer this, by the way.
Yeah.
What if an AI was built for this purpose, to sort of inspect how non-public companies are operated and say like, hey, I'm going to try to maximize efficiency. And I've studied, like my training data has been 30,000 of the most successful and least successful startups in the last 30 years.
Yep.
What if it actually learns that the most optimal way to become as successful as possible is doing illegal stuff, just not getting caught? And that is the optimization. Would that,
I mean, we've
what would
already
that
had the problem
expose?
this problem exists in this credit scoring world and has existed for a long time, which is how do you score, people's credit default risk? And there's a legal framework around that today on things you can or can't do and how you can make certain decisions in terms of assigning financial resources in the form of loans or just credit being extended. The efficiency maximizing answer from the machine is illegal.
Mm-hmm.
And will get you in real trouble if you go for 100% efficiency, zero compliance. And I think we just have this is that again that age-long interaction between technology and people of making sure that we develop rules, compliance rules, and ethics rules for how we want these systems to work, and then architect them so they work that way. I mean, I know it's a a little bit of an apple pie in America kind of answer, but it's you can use technology for horrible things and wonderful things, and we have to think about what the correct way to use that technology is. And the 100% efficiency answer is probably not always going to be the right answer. I mean, it took me a long time as an individual to learn that sometimes being kind is better than being truthful or candid. And it doesn't mean you're lying. It means be kind rather than tell people truth that hurts if that truth is not helpful. Technology is kind of the same way. You may not want to be 100% efficient if it leads to outcomes that are just not right. Then, I mean, at the end of the day, efficiency is not why we live our lives.
Right.
And that's, that's how I answer that question, which is you got to go back to what rules do you want to put around ethics and compliance so that the system does what you want it to do.
What if we built an agent that does this, that sort of controls how a company functions?
By the way, I believe it's only a matter of time. I mean, it makes so much sense, and the technology arguably is already there today. It's just a matter of packaging it the right way. And it makes, if I'm an owner of a company, it makes 100% sense to me to do that.
But what if we get the government involved, regulators, to say, here are the rules that you will abide by because these are law and these are your constraints. Like you can't do this sort of thing to your employees. You can't do this to acquiring financing. You can't operate your business outside of the scope of this thing that you're supposed to be doing. And we release it and we make it, attempt to create a couple of companies using something like this as a management tool. What does it say about our society if that always loses as compared to human-run organizations? And it's uncovered that the real reason why the humans are winning is because they're skirting around the regulations. Do you think something like that would be a paradigm-shifting event if AI comes to such sophistication that it can manage complex human-only currently things, and we apply the correct rules associated with it to say this is how we want this to operate, and it's sort of the best version of ourselves as far as artificial morality goes. But it uncovers that the rest of society is doing things like pretending to follow the rules, but is actually not doing things correctly.
I'm going to give you a very Chicago-y answer. I make the most sense of what you just said in the context of financial markets, which is there's always this perennial question around, can you really eke out a profit, in capital markets without committing some kind of insider trading crime? And there's a whole debate on it. I don't necessarily want to get into it, but you might argue that to really generate these kind of hedge fund-like returns, you have to have some kind of inside information, which is simply not uncovered. But to your point, once we start shining a light on it, we'll realize that all these supernormal returns are driven by things that are not technically legal. That might very well be. Now, there's also the flip side of that is if you look at all 200 countries in the world in terms of these being experiments in market making and what's an efficient market, what's not an efficient market, until you start arguing against that, I think there's enough evidence that shows that markets that are not corrupt, where people are cooperating in a trust-based environment, where there's limited evidence, or there's actual evidence of limited skirting of the rules, these markets tend to be more efficient. The resources tend to be allocated in a more effective way, and that leads these economies to be better functioning than corrupt economies. I would take that to be, my kind of positive thinking element of efficiency, proper efficiency, true efficiency in the sense of the efficient market hypothesis ultimately wins out. And all these technologies we're talking about, in my mind, ultimately, they're just ways to have, they're really ways of transacting in a way that is more seamless, more efficient, less corrupt, less unethical if structured correctly, and make us better off as a result as a country.
And as a species. Couldn't have said it better.
Yeah.
It's excellent point.
I know we're coming up on time, but lots of thoughts. One point that's I think is really relevant is that Ben, I think, was hinting at the concept of technology and sort of especially data-driven technologies that are trained on human information. They often reflect a lot of characteristics about humanity. Make a Twitter bot, it's suddenly racist. How did that happen? Oh, wait, many people are posting lots of racist things. So it's really interesting to see how technology can sort of reflect the good or the bad, because it's I wouldn't call it at the human level, but it's sort of mimicking human behavior using a different set of rules and a different set of logic. So if it comes at a different conclusion than what humanity does, or the same conclusion via the same set of rules, that's really, really interesting.
Yeah, but I think that bias in my mind comes from the generative AI angle that you're applying to this. This whole notion of LLMs and generating new content, which is really, to me, in the realm of fiction. I mean, whereas a lot of optimization and resource allocation work that takes place, which is why LLMs are so problematic, by the way, because of the hallucination issue. But a lot of resource allocation decisions are not about being creative or generating anything. It's about optimizing, which is a different problem you're solving.
Yeah, that's a good point. And optimizing the right problem. That the right problem needs to be framed incredibly carefully.
Yeah, for sure.
All right, so I will wrap. There was like a legitimate crap load of really good information here, so probably just re-listen to the episode. But some things that stuck out to me. If you're looking to do causal analysis, this is a general 3-step process you can follow. And doing these each step like very correctly is super important. First is collaborate with subject matter experts to structure your question and structure where you're looking. Second is get high quality data. And third, actually do the causal analysis with the correct tools. Propensity score matching is a classic example. I'm a big fan of GLMs, or generalized linear models, which basically add a link function on top of a linear model. So a lot of the linear model assumptions hold. A/B testing is sort of the gold standard of causal inference, but it's typically expensive to build. So that's a very good process you can follow. Then a bunch of random quick hitters that I couldn't categorize very well. First, your initiatives, the things that you work on should be demand driven. Model explainability is super important for internal adoption and can also really guide a lot of additional business decisions. Deep learning, great for unstructured data, but often it's not super great for tabular data. And if you need causal inference or at least high levels of explainability, typically you want to bump down to a simpler method. One thing that I hadn't heard discussed at length before, but I think was really, really interesting, is thinking about the negative outcomes and not just the positive outcomes. And so essentially making sure your data are representative. But a flip side of that is not just thinking about representative samples, but also thinking about what happens when the not desired behavior occurs. So if someone purchases, that's a 1. If someone doesn't purchase, that's a 0. There's many kinds of zeros. They could leave the platform, they could burn down your house. There's all sorts of zeros out there. You need to think about that distribution of zeros. And then finally, go back and see if your decisions hold over time. Sometimes they won't because you had a bad A/B test. So, Pierre, where can people go to learn more about you, your work, and what you're doing these days?
Oh, I mean, by all means, come to our website, g2m.ai. We also have, as you guys know, our no-code platform that does a lot of the TGM part of analytics for you at Analyzr.ai. But as simple as just come to g2m.ai and you can go there from here.
Cool. All right. Well, until next time, it's been Michael Burke and my co-host,
Ben Wilson.
And have a good day, everyone.
See you next time.